Now we are given this differential equation of the form y prime, which is just equal to dy over dx, which is equal to ax lowercase ax plus by plus c divided by uppercase ax plus by plus c. We are asked to prove this following. For a, we are told that if a lowercase a multiplied by uppercase b is not equal to lowercase b multiplied by uppercase a, if they are not equal, you can use the substitution y is equal to u plus h and x is equal to v plus k. H and k are constants which have to be solved later. And for b, we are given the situation that a uppercase b is equal to b uppercase a. If these are equal, and if lowercase a squared plus uppercase a squared is not equal to 0, and same goes for b and c, if they are not equal to 0, we can use these substitutions. V is equal to ax plus by if a is not equal to 0, or v is equal to uppercase ax plus by if a is equal to 0. And lastly, we are asked to solve what is this is not crashed out. If lowercase a squared plus uppercase a squared is equal to 0, and lowercase b squared plus uppercase b squared is equal to 0, the given equation is a separable equation, can be transformed into a separable equation. And if the the squares of the c's is equal to 0, it can be transformed into a homogeneous equation. So we're asked to prove the following. For a, we can use the substitutions given here to get du over dv, which is equal to a multiplied by this given terms. By distributing the a's and the b's, we get this following term. In order for these terms in the parenthesis to become 0, we have to equate it as this ak plus bh plus c, which is equal to 0, and uppercase ak plus bh plus c is equal to 0. These are just constants, and they do not have the dependent variables or independent variables. So once we equate this to 0, we can get the values of h and k, so that these terms can be cancelled out, and what remains will just be du plus over dv, which is equal to av plus bu over av plus bu. By cross multiplying it, we get this final form: uppercase a to the v plus uppercase b to the u du plus av plus bu dv. By inspection, we can see that this is a homogeneous equation. To solve for b, it is better that we use an example as for illustration. So we have the equation, this given equation. We can rewrite it into the form given previously as this form. We can see that 4 multiplied by negative 1 is equal to negative 4, and 2 multiplied by negative 2 is equal to negative 4, which corresponds to the condition given at b. So we use the substitution. V is equal to 2x minus y, and by rearranging the terms here and differentiating it, we get y prime which is equal to 2 minus v. Substituting it to the original equation, we have v, which is equal to 2 minus v prime, is equal to 2v minus 5. Now why is it 2v here? We can see it here that 4x minus 2y, if you factor out 2, we get 2 is equal to, which is equal to 2 multiplied by 2x minus y, and v is equal to v, so we get 2v. And by distributing v in these terms here, we get 2v minus v prime is equal to 2v minus 5. But we can, now this 2v here can be cancelled out, and we get 5 is equal to VV prime. Now V prime is equal to V prime. V prime is equal to dV over dx. So V dV over dx is equal to 5 and V dV is equal to 5 dx. Now from this form we can clearly see that it is a separable equation, which proves the condition given the problem. So we continue to solve this. Integrating it, we get 5x is equal to v squared over 2 plus c. And finally, by substituting the value of v, we get the solution 5x is equal to 2x plus y squared over 2 plus c. Now to prove this for c, we a squared is lowercase a squared plus uppercase a squared is equal to 0, and lowercase b squared plus uppercase b squared is equal to 0. If these conditions are met, the equation given here can be transformed into a separable equation. And if c is equal to 0, the equation can be transformed to homogeneous. If we can see that if these terms are equal to 0, so we can make one that this can only become to 0 if a and a is equal to 0 and b and b is equal to 0, since there are no values of any number when squared will turn out to be a negative number, so it has to be positive, and the only way to make it 0 for this equation is that every term is equal to 0. So by substituting it, we cancel out all of these terms that has x and y's in this side of the equation. So we get dy over dx is equal to c lowercase c over uppercase c. These are constants from as given. Now c is equal to c dy is equal to c dx. From this form, we can see that it is a separable equation. And now for c lowercase c squared plus uppercase c squared is equal to 0, we can eliminate these c values at the original equation to get dy over dx is equal to ax over by plus ax plus by. By cross multiplying it, we get ax plus dy is equal to ax plus by plus dx is formed. By inspection, we can see that this equation is a homogeneous equation.